Thanks for your patience. So I'm so excited to introduce the next moderator for our panel. It's a great segue, actually, to find out how platforms and technology work, because the moderator of our next panel, Arun Sundararajan, is the world's expert on the sharing economy, having just written a book of that title. So he's going to introduce his panelists. So Arun, why don't you come on out? Thank you so much. Yeah.
Kathleen. Thank you. Yeah, I'm going to help you move the tables forward. As one of the distinguishing characteristics of the FinTech Conference here is that the furniture moves sort of dynamically. The real reason why they have me moderating this panel is my ability to sort of move tables seamlessly between sessions. So, so Vasant and Michael, why don't you come on out as well? So I'm Arun Sundararajan. I'm a professor here. I've been a professor here for a while. Today's session, the next 45 minutes is about automation in financial services. This is not new. Automation has been happening in financial services for at least 2 decades, if not more. But it seems like we've hit some tipping points over the last few years. Certainly sort of in the artificial intelligence technologies, the move away from coding and towards induction, the move away from programmer-defined features and towards sort of systems generating their own features on which they learn. The progress that we've made in solving the problem of perception. So all of these have been sort of tipping points that make us wonder, well, will the pace of automation pick up? We've also seen the presence of sort of the growing presence in financial services of large tech platforms like Apple and Amazon and Facebook and Google and Alibaba. These are some of the sort of the largest concentrations of AI talent that exists. And so it makes you also wonder whether the pace of automation will pick up on account of sort of the increased talent concentration here. I guess what this leads to is a question about, when do we delegate our decisions? What kinds of things are societally okay to delegate to the algorithms? And when we do delegate things to algorithms, what kind of societal issues do these raise? And that will really be the focus of what we talk about. And we're going to structure our session in the following way. My colleague, Professor Dar, will sort of kick things off with a few opening remarks for a few minutes. And then Professor Michael Kearns from Penn will speak for about 15 minutes on algorithmic bias and how that applies to financial services. We'll have a couple of questions over here, and then we'll throw it open to the audience. So without further ado, let's get started. Professor Dar Vasant has been my colleague for many years, has been in FinTech for 25 years, long before it was called FinTech. He ran our Center for Business Analytics for a while. He's the editor of the journal Big Data. He's published widely sort of at the intersection of finance and machine learning. And he was also the founder of one of the first purely machine learning-based hedge funds that started almost 15 years ago. And he's a senior advisor to McKinsey on issues relating to artificial intelligence. So, Vasant.
Thanks, Arun. So I'm going to take about 10 minutes to just briefly summarize what I see as the 2 major drivers in FinTech. And I've asked Arun to shock me at 8 minutes, which means I need to look at him 8 minutes from now.
That's the other technology they give us when we moderate.
So, so the first big driver is the emergence of FinTech platforms. And this is not new. This has been a sort of a key driver of the internet economy. Just last month, my colleague Roger Stein and I published a paper in the Communications of the ACM called FinTech Platforms and Strategy. And I'll just take a few minutes to describe what we mean by that, both by platforms and strategy. So essentially, we draw on the literature on platforms and point out that they have 3 properties or components. One is open access, easy participation. The second is that they implement some key business process. And typically, that business process sort of enjoys network effects. The more people that sign on, the more valuable the platform becomes, the more data it generates. So it's sort of virtuous cycle. And then the business process is implemented through some key technology. So automation is really the kicker that turns the platform into overdrive. in the fintech space, and so one of the things we point out is that historically, financial services platforms have been incomplete in that they've lacked one or more of these components, and this is either for technological or regulatory reasons, and that sort of strategy in this space is something that we call platform completion. That is, you actually complete one or more of those functionalities and make the platform more complete and open and more accessible. And essentially, you can think of that as sort of being arrows pointing to the center. And we've seen the emergence of certain kinds of platforms in the robo-advising space, for example, and also in the peer-to-peer lending space. And there's an attractiveness to being in the center of the platform. One of the things about the internet economy is sort of the winner-take-all sort of aspects of these platforms. So once you're sort of lodged in the center, it's not easy to dislodge you, right? So that's a big motivation for platform completion and getting into the center of the platform. The second strategy that we point out is something called component replacement, where some component of this platform gets replaced by a superior technology. And one of the sort of more compelling examples of that is blockchain, which could essentially displace a lot of the intermediary functions that are currently performed by institutions, right? So that's an example of a technology that could replace existing sort of infrastructure. And we're seeing the weaknesses of some of the sort of existing infrastructure, increasing number of hacks. Like a lot of these institutions were just not defined for internet era kinds of businesses. And so this is one of the big reasons for the excitement behind a platform that would just streamline the whole sort of post-trade or post-transaction part of the infrastructure, right? So that's a component replacement strategy. And later on in the afternoon, we're going to see other examples of platforms in the payments space, for example, and also in India, where there's a lot of sort of really interesting stuff going on around platforms related to authentication, payments, and data having to do with sort of privacy and sharing of data. And so there's platforms emerging for all of these things that are really exciting. So it's a great space to be in, and that's one of the major drivers. The other driver, of course, is data and all of the associated technologies that come with it, including specifically machine learning. And one of the things that I point out to people is that we're seeing this rise of autonomous learning systems, where systems have the capability to learn automatically from data. And this is something, as Arun said, I got started in many years ago in trying to ask myself whether I could design a machine that could learn to trade at a similar level that humans have based on access to data. And that sort of turned into a really interesting exercise, because I realized that while I was using machine learning methods to find patterns in data, in fact, at the end of every sort of cycle, like every month, I would be faced with a decision of like how much, which models do I trust? How much risk do I allocate to various things? And over a period of time, I realized that that was a thankless exercise, and I had no ability to really do that in any superior way, that I was often doing worse than random. And that really caused me to think about this as a process, that you're really sort of designing a process. And I wrote about it in a paper called Should You Trust Your Money to a Robot, where the question I asked is, might it be easier to find a good robot relative to a good human, like Warren Buffett, right? So it's an interesting question. And of course, I answered that in the affirmative, because humans just tend to be poor investors, right? We just tend to sort of do the wrong things. Like I did over the last 2 weeks. I sold my Apple stock. I sold NVIDIA several months ago. Just like terrible decisions. I feel like I feel like a chump for doing that. And so I've realized I really should give my money to the machine. And so I've started doing more and more of that, other than Warren Buffett. But the same question applies increasingly to a number of problems. Should you trust your tax return to a robot? And mine is simple enough that I probably would trust a robot to do that. Okay. And then there's a number of other questions. Should you trust your child's education, transportation, et cetera, et cetera, et cetera? And the question is, how do we make this decision? And so I proposed a simple way to think about it, which is in terms of 2 dimensions, and this was published in the Harvard Business Review. And if any of you are familiar with that, you know that unless you can explain your problem in 2 dimensions, it's not going to make it. And so fortunately, I could explain it in 2 dimensions. One of them was predictability. So every problem lies on a spectrum from complete randomness to complete determinism, and I've laid out these problems there. And so you might think that high signal problems are the ones we should automate, whereas low signal ones are human. But that's just not true, right? High frequency trading is automated, and the winning rates there are just north of 50%, and yet driverless cars aren't. I took my first autonomous driving exercise in Manhattan the other day, and it took me all of 15 minutes to convince myself that the car wouldn't kill me. But that's only because I did have access to the controls. But I suspect that years from now, as we see that this stuff seems to work, we'll sort of cede control to the machine. And so the question is, what really matters here? And the answer is that it depends on not just predictability, but the cost of error, right? So the x-axis is how often do things go wrong, and the y-axis is when things go wrong, how badly do they go wrong? And this gives us this what I call a frontier, an automation frontier, where to the bottom right, we tend to trust machines, and towards the top left, we don't. That's the domain of human beings. Not that human beings do it well necessarily, but it's just that we don't really trust machines in that zone. So problems are not static. Data, better algorithms move problems to the right and towards the lower part of this figure, and that's the challenge for many data scientists, is how do you really move these problems towards the bottom right and make them amenable to automation, which is another way of saying you now trust the machine to make the right kinds of decisions. Have I gone past 8 minutes?
Yep.
OK, so let me just summarize. And I'll say that autonomous learning systems encode a process. And that's ultimately what that we put our trust in. The challenge is how we move problems to the lower right. The framework, of course, says nothing about important things like regulation, like financial services is the most regulated industry in the world. So the issues that really go into fielding these kinds of systems in reality have to do with concerns like, are they fair? Is the process fair? Is the process perpetuating existing bias in the data? Is it morally acceptable? Is it violating privacy, right? So these are all really vexing problems that we're trying to address at the moment that are essential to how we actually end up using these kinds of systems. So these are the kinds of critical issues we need to think about, because at the end of the day, all of these systems are systems where we're handing over control to the machine, which is making decisions at scale. Thank you.
All right. Thank you, Vasant. That sort of sets us up really nicely for Michael's talk. So we're delighted to have Professor Michael Kearns join us for this session. Michael's bio is sort of so long that you keep scrolling through the web page and you think you're done, and his list of accomplishments is. So I put what I could onto a little car. He's the National Center Chair of Computer and Information Sciences at the University of Pennsylvania, where he also has affiliations with economics, statistics, and with the Wharton School. Those of us who are familiar with Michael's research know him as sort of the quintessential interdisciplinary scholar who sort of pulls from different disciplines to sort of give us a new perspective onto sort of the most vexing research problems that we face. He's also the chief scientist of Mana Partners, which is a trading, tech, and asset management firm in Midtown, and advises a wide variety of organizations that include Microsoft Research, FINRA, and the Alan Turing Institute. And Michael will be talking to us about fair algorithms for machine learning and sort of their applications to financial services.
OK. Thanks, Arun. And thanks to Arun and Vasant for inviting me to speak. I've known them for many years and done a lot of fun events here with them. So I want to kind of follow up in a slightly more technical vein on some of the things that Vasant said at the end of his presentation. And I want to talk in particular about fairness or fair algorithms for machine learning. And I'm not going to cast it in the context specifically of fintech or consumer finance, but I think you'll be able to easily map this onto that, because I think one of the main things that's changed in the sort of modern machine learning era is not just the things you read in the New York Times about machine learning solving important problems like detecting cats in images and playing Go. But really, the more important development is the fact that it is now the case that on a regular basis, at scale, machines are making autonomous decisions about things that are of consequence to specific citizens' lives, like whether you get a loan, what criminal sentence you receive, what college you get into, whether you get the job that you want. And so it's not surprising that kind of quickly on the heels of that, in addition to the articles about AlphaGo, for instance, there's now a plethora of articles about demonstrated instances in which machine learning exhibits discrimination or bias against some particular group, whether it be gender-based or racial or what have you, whether it's in the domain of what ads you're shown on Google to what criminal sentence you receive. This is happening quite often now, and it's kind of the dark side, if you like, of AI and machine learning, or one of the dark sides. And so I've spent a lot of time thinking about this problem, both from a technical standpoint and also from more of a legal and regulatory standpoint over the past couple of years. And one of the things I find when I talk to people who are outside of the machine learning community is this kind of belief that they have that the code underlying most machine learning systems is some incredibly opaque, complicated, tangled spaghetti of code that might, let's say, rival the complexity of Grand Theft Auto. And this slide is meant to show you that actually nothing could be further from the truth. This is lifted straight from the Wikipedia page on stochastic gradient descent, which is simply the simple algorithm that underlies training of neural networks, for instance, so deep learning. This is basically the code for deep learning I'm showing you. And so the first thing I want you to notice is that it's incredibly simple. I mean, of course, if you had to really implement this, it would get a little bit longer, but not by an order of magnitude. And nothing could be more basic and objective and scientific than this piece of code. I've highlighted in red kind of the action part of this code. For each example in some data set, compute the error of your current model and adjust the parameters of your model so as to reduce the error, okay? And so not only is this incredibly simple, but there's nothing blatantly discriminatory in it. It doesn't say, if the applicant is from this racial group, then branch over here, okay? So if there's discrimination and bias in modern machine learning systems, it's not sort of directly detectable from this code or attributable to kind of the complexity and opaqueness of this code. It's got to be, somewhere else or more than one place perhaps. And so, one question is, how does discrimination and bias arise? And, I'm here to tell you the good news is that there's multiple places that this can happen. So first of all, it could happen kind of at the input in the data. So, most data sets that are used for, sort of consequential decisions about individual citizens are gathered from some existing process that might have predated the era of machine learning. So, for example, in things like predictive policing, you're much more likely to make more arrests where you've already put more police in the past. And so if you use that data and feed it, for instance, to the code that I gave you on the last slide, it wouldn't be surprising if the resulting model learned that you should kind of continue to put more police where you've been putting them, not because there's sort of inherently more crime or bad people there, but maybe just because you've generated bias in the data through your own collection process. There can also be bias at the output, right? So there can be discriminatory treatment of subpopulations just from the demographics or the relative weighting of the data. So in general, if you have a large population and there's a minority subgroup, by definition, you have less data on the minority. And if you're building a model that's designed to fit the data well, it's probably going to fit the properties of the majority well. Okay, so many of you may have read recent articles about medical studies that tend to be highly biased towards subjects who are white males. And so the results of the models are strongly biased towards the specific properties and medical and biological properties of that group, okay? And so the third way that this can happen, of course, is in between the input and the output, which is in the algorithm itself. And one way that the algorithm itself can generate bias is that a lot of times, for instance, in consumer lending decisions, there's sort of counterfactual data that you don't see. So if you have an algorithm that's making mortgage decisions, for instance, you find out whether the people you gave mortgages paid them back or not, but you don't find out whether the people you denied mortgages would have paid them back if you'd given them to them, okay? And one point I might make is that a lot of traditional ways of thinking about fairness and discrimination in statistical modeling tend to kind of primarily care about just the output, sort of like, is the model that's been trained by the process fair in some statistical sense, okay? And I think that this is a bit of a fiction these days because it kind of harkens back to if you've taken like a basic statistics course that teaches you like train test methodology. So you have a data set and you use some of it to train the model, but you save some of it out to test the model because of course the reason you're fitting a model to data in the first place is not to fit the data that's in front of you well, but to generalize out of sample, okay? And the observation I would make these days is that that separation between a training period and a testing period is basically a fiction these days, right? Where learning is happening perpetually. So every time you click on an ad on Google, that is immediate feedback that's directly incorporated right away into the improvement of the models that are making those decisions about, let's say, what ads that you're shown, okay? And so if you kind of forgive a machine learning system for some prefix of its existence for making unfair decisions during the training process, you're basically like letting it off the hook forever, okay? And so it's important to not just think about algorithms that produce fair output at the end, but the algorithms that are operating and adapting perpetually and need to make fair decisions all along the path of their existence, okay? And so what a bunch of colleagues and I have been doing for the last couple of years or so is trying to make a science out of this, is actually trying to make a science out of the design of fair learning algorithms, okay? And so at a high level, the methodology involves picking a particular learning framework, like whether it's a supervised learning problem or more of a sequential decision-making problem or a clustering problem or the like, and pick some technical definition of fairness. I'll say a little bit more about possible definitions shortly. And then basically to explore the consequences of that definition in that particular learning framework and try to design algorithms that have some sort of guarantee about fairness, okay? And more importantly, or equally importantly, not just to design those algorithms, but to understand what the costs of fairness are. And I'll come back to that in a minute because there will be costs to fairness, right? We can't, you know, the idea that you can expect to have an optimally accurate model and a fair model simultaneously is a fiction, okay? And I'll make that point clear at the end. Okay, so just to quickly say, you know, it says, you know, the interest in fairness in machine learning is at a high point right now, but concerns about fairness has been in statistical modeling have been around for a while. And just to give a little bit of a flavor of how one might try to be a little bit more quantitative about what you mean by fairness in machine learning or in a learned model, you know, one definition is a kind of statistical parity. So that would be a very crude notion where you say like, well, the rate at which I give loans to group A has to equal the rate at which I give loans to group B, period, okay? A more refined notion would be kind of equality of false rejections, for instance. It's okay if I have different rates at which I'm giving loans to two groups, as long as the rate at which I make kind of consequential mistakes is the same. So the fraction of time that I deny white people who are actually creditworthy a loan has to match the fraction of black people that I deny a loan that are creditworthy, okay? So this is some kind of notion of fairness. It doesn't promise anything at the individual level, right? So if you are one of the people in one of those two racial groups that was denied a loan and you should have been given one, it's kind of cold comfort to you that it's like, okay, well, we made a mistake on you, but trust us, we're making the same fraction of mistakes on this other group over here, so you should feel better about that, okay? So this is a flavor of the kind of work that many of us are doing these days, and let me just quickly, you know, summarize what we know. It's still early, so we don't know a lot yet. There is older work from the statistics and data mining community that tends to be a little bit more heuristic and doesn't make kind of, you know, formal promises about fairness. And one thing I might mention is that one thing we do know is that unfortunately there's a little bit of definitional messiness in fairness. Okay, so what do I mean by that? I mean that, so for those of you that have an econ background and have heard of things like Arrow's impossibility theorem, there are sort of impossibility theorems for fairness. So there's been a couple of papers in the past 2 years or so that basically have the following form. The paper starts off and say, well, look, here are 3 properties that we can all agree any definition of fairness should meet, right? And then you look at those properties and you say, yes, yes, these are minimal properties. We would definitely want these and probably stronger things. And then the punchline of the paper is, well, guess what? Here's a theorem that says you cannot possibly achieve all three of those criteria simultaneously, except in trivial cases that will never arise in real problems, okay? So unfortunately, there's not going to be some single definition of fairness, and it means that when you pick one definition of fairness, you might be trading it off against another notion of fairness that you think is equally valid, okay? But that's the way life is, and one has to proceed with the hand that one is dealt. Maybe the most important message I want to give is just in this slide, and then I'll wrap up so we have some time for Q&A and discussion. This is a plot from an actual data set in which fairness is a major concern. It's the so-called Compass criminal recidivism data set. I don't know if some of you that might have followed the whole controversy about the use of statistical modeling in criminal sentencing decisions that's taken place over the past couple of years. This is that same data set. And I won't describe in detail what the two axes are, other than to tell you that the x-axis is a measure of how unfair a statistical model is, and the y-axis is a measure of the predictive error of that model, okay? And I'm showing a curve here where each red circle corresponds to a different model, okay? And note that where you'd really like to be in this picture is in the lower left-hand corner. You'd like to have the smallest possible unfairness and the smallest possible error in your predictions. And notice there are no red points down in that lower corner, okay? And so, those of you who have a finance background, this is like the efficient or Pareto frontier of accuracy versus fairness, and you just cannot get off of this curve. You cannot do better than this curve. You can choose to have a model like the one on the far right, which minimizes your predictive error, okay, but then you're going to have the highest unfairness. You can also choose to be at the upper left, where your predictive error is high, but you have a very fair model, or you can pick anywhere you want in between, but you can't get off of this curve, okay? And so an important thing, I think, for society to think about in a kind of application by application way is there's always going to be a curve that looks something like this, and you have to pick where you are on it. And where you pick should probably depend on how important the decisions you're making are. For instance, maybe if what's at stake is criminal sentencing, you really want to be more to the upper left there and be sure that you're being fair to subjects, even if it's costing accuracy, but it will cost you accuracy. Whereas maybe if it's what ads people are showing on Google, we're less concerned about fairness, okay? So let me stop there and just say that more generally, this type of research is part of, I think, a pretty important trend within the machine learning research community to try to start thinking about machine learning and social norms and AI and social norms, and not just worrying about them, because every article I pick up on this topic in the New York Times, Wall Street Journal, or wherever is worrying about this topic. But the question is, what can one do about it? Okay, and the traditional response to this would be like, well, we need legal, regulatory, and watchdog frameworks to sort of police the models and algorithms that are used in these systems. And I don't disagree that that's going to continue to be, as it always has been historically, an extremely important piece of the puzzle. But unfortunately, those types of methods, to use computer science terms, don't scale. If we're going to count on human-based organizations to actually audit and regulate by sort of like looking at the behavior of models by hand, so to speak, it won't scale, okay? And so I think a big part of the answer here is to endogenize these social norms into the algorithms themselves. And just to be clear, I'm not proposing that machines decide what fairness means or what privacy means or what morality means. I think that those decisions should and always will be made by humans. But once you've committed to what you mean by them, then there's a chance you could actually encode them in your algorithms. And this is where I think the kind of important research work lies, at least. Thank you.
All right. Thank you, Michael. That's awesome. So we have something approaching 20 minutes left for discussion. And I'm going to do the following. I'm going to ask each of you one question, and then I'm going to open it up to the audience. So my question for you, Vasanth, is, many of us are fans of your framework. That's sort of actually in So like, I mean, we're all thankful to Harvard Business Review for having sort of forced you to simplify it into that 2x2. But if you sort of look at that mapping and you look at the kinds of decisions that are being made in financial services industries today, and you look forward like, the next 5 to 7 years, what are the financial services domains in which you'll see an increase in the rate at which we start to delegate decisions to robots?
So, I think the key to that is to look at those areas where there's more and more data becoming available. And broadly speaking, I'd say that it would fall into the following categories. I think you're going to see more in the investment side, and you're already seeing that with robo-advisors, that at the moment do very simple kinds of things like portfolio optimization that humans tend to be sloppy at doing, right? So they take the grunt work out of that and keep a portfolio balanced. But they'll gradually start creeping up the value chain and start doing sort of more of the stuff that I started with, which was the decision-making part.
Yeah.
Whether people trust robo-advisors with that kind of thing remains to be seen. It'll depend on how they work out, the quality of those decisions. But I would expect those platforms to start trying to creep up the value chain in terms of not just how to optimize, but what to do, what to invest in. Lending is going to be another big space. There's lots more data in that, so you're going to see more sort of automated decision making in the lending space. The concern there has to do with sort of the opacity of the models. The concerns I see out there are if I put an automated learning systems out there that's making lending decisions, how do I know that people won't start gaming it if they find out the basis on which the system is making decisions? So those are the barriers, but I'd expect, that notwithstanding, to be more activity in that space.
Yeah, and then that's a game we've been playing with spam filter systems, with sort of search engine ranking systems.
Right. Same problem, different context, right? So we'll see more of that. I think we'll see more in the targeting space, right? We're just seeing more payment flow, all kinds of transactional flow, so there'll be more targeting going on. And then, of course, there's sort of processes in general, right? And you're seeing that in sort of, if you look at the typical sort of investment portfolio of a VC, you see these areas, and you see, reg tech, process tech, where people are sort of, addressing small parts of the process, compliance, regulation, just those kinds of things that are repetitive. But once you have enough data, you can actually learn how to do those things better. So we're seeing innovation in that space already.
Okay. I mean, it's interesting because there's sort of this breaking up into three pieces, right? I mean, one is where will the automation take place? Where will decisions be delegated to robots? And there's an associated problem, which is as these are delegated, will the individuals trust the systems? And I think in some cases that are more consumer-facing, that's an important determinant of the first issue. In other cases, where it's sort of buried more deep into sort of the organization, it's less of an issue. Then there's the third question, which is how is this going to sort of affect societal outcomes, right? As we sort of move more, we talked about what robo-advising, lending, mortgages, payment systems. So my question to you, Michael, is actually really simple, which is, there's this, what you talked about was really fascinating. Economists understand this sort of trade-off between optimality and some notion of fairness. And as a community, we've sort of ignored the second issue in favor of the first, right? We maximize total surplus and don't worry about distributional effects. But then you came up with a couple of definitions of different kinds of fairness, rate at which you sort of, come up with positives, rate at which you sort of make certain kinds of errors.
Right.
And then as you concluded, it was sort of the message was that this would not scale if human beings are involved in sort of assessing the fairness. So my question is, so what do we do? I think it's clear from the hearings that are going on Capitol Hill in a different context that algorithmic bias can sort of have huge societal consequences. I mean, based on the research that you're seeing and you're doing, I mean, like, where do you see the solution lying for the financial services space?
For financial services per se?
Or just in general?
Yeah, I mean, I think we're at the point where the concerns about discrimination and unfairness in statistical modeling sort of transcend any one particular sector, but generally are highest in things that touch consumers' lives in a very direct way. I mean, in terms of what needs to be done, I think from the research side, the kind of work that I was talking about is exactly the right kind of work. One thing I might sort of point out is that I think when you're trying to make promises to users or people about social norms being preserved or defended by an algorithm, there's a particularly important role for theory to play.
Okay.
And what I mean by that is, how do you give people promises that an algorithm meets some social norm, right? So an analogy I like to make is that, but that of cryptography. So for like 2,000 years, cryptography proceeded by code makers basically taking messages and devising some algorithm or scheme that kind of scrambled things around and saying, well, sure looks random to me, until somebody comes along and reverse engineers that scrambling, and then suddenly it doesn't look random at all. Okay, and cryptography sort of made a huge leap forward in the 70s when it moved to public key cryptography, and the algorithm didn't have to be kind of obfuscated anymore. And the kind of security of the cryptography was based on sort of a hard mathematical promise and proof, right? So this was kind of what, and this is what led to RSA, and this is what underlies HTTPS. So again, this doesn't mean that there aren't hacks available or kind of poor implementations of modern cryptography, but the point is that you kind of sort of 2 millennia of people just sort of doing heuristic things that they couldn't make any promises or guarantees about, and then would subsequently be broken. I think kind of sort of having firm mathematical grounding for these problems is sort of relatively important in settings where the decisions are touching individual civilians and consumers.
But to me, the paradox is, and just so that in the interest of sort of being efficient, if you do have a question for either panelist, there are microphones on both sides, and so if you want to just sort of start lining up, that will allow you to ask your question first, and it'll also save us a little time. When you concluded, you talked about how we don't want to delegate these decisions to humans, which sort of means that we want to delegate them to algorithms, right? And we were talking about YouTube and how a lot of regulation has been delegated to YouTube, and they are making these decisions algorithmically now. But if these algorithms are inherently sort of subject to the kind of bias that we're trying to prevent, I mean, what's the fix? Is it sort of the absorption of these norms?
Yeah, so again, I'm not sort of saying that humans shouldn't be in the loop here, but if literally human beings were the ones, if human beings, if regulatory and watchdog agencies actually have to catch all instances of malfeasance directly, I don't think they're going to be able to keep up with it. I think this is already failing, okay? And so maybe a better way of putting it is that you have to put kind of the right algorithmic tools in the hands of regulators and auditors, right?
Okay.
And so, one can actually formulate the problem of kind of detecting whether a statistical model has bias as sort of an instance of machine learning itself, right?
Yeah.
So, because you're basically looking for like a subgroup or a correlation between the input features in which, let's say, the false positive rate conditioned on those features is very different than the background rate. Yeah. And that itself is a machine learning problem, right? So, not to make this sound like it's going to be kind of battle of machine learning algorithms, but I think that those kinds of tools are going to be important. And by the way, one thing I would mention is that one very kind of bothersome thing about traditional definitions of fairness is they sort of assume that you've predetermined what subgroups you're trying to protect, like I'm trying to protect a racial subgroup. And this lends itself to the possibility of what I call kind of fairness gerrymandering, where you meet the technical definition of fairness by discriminating against a subgroup of the group that you want to protect. So, for instance, if I'm forced to show an ad for my country club to some group that I don't really want to join my country club, but I'm forced to show it to them at some rate, okay? I can try to use machine learning to find the subgroup of that group that I know can't afford my country club and meet my quota by showing it to them. Oh, wow. So now I've kind of subdivided the group that you told me you wanted to protect and deliberately targeted a group that I know, won't be able to take me up on the offer that I make them, okay? And so I think that it's even worse than sort of protecting against false positive or false negative disparities between groups. You need to be worried about kind of an explosively, combinatorially large combination of subgroups.
Okay. So we seem to have 3 questions so far. Why don't we take all 3, one after the other? We all have pens and little index cards. And then I'll invite the sort of the panelists to answer any subset of those 3 questions. So why don't we start on this side?
Yes, so in the conversation about robo-investing and even ethics here, it seems to me it's all very much oriented around passivity, meaning the machines are making decisions on behalf of institutions for consumers. And I guess I'm interested in understanding what your thoughts are on allowing machine learning to empower the individual to be a component of those ethical decisions, meaning you're filtering information to allow them to be more active participants in a decision process as opposed to passive.
Okay, great. And what was your name?
My name's Emil Westergaard.
Okay, thank you. So that's the first question, passivity and making algorithms components of the decision.
And Paul Mahdi from MAS Finance. My question is really, isn't the sweet spot for AI application in financial services payments fundamentally because we have the convergence of digitization in payments, we have the convergence of deregulation where there's a mandate, PSD2 in Europe, and we have a whole movement globally to instant payments. So you have at least 20 countries that are moving to instant payments, fast payments. Here in the US, TCH, the clearinghouse, is moving to RTP, real-time payments. There's no way human intervention can address instant payments from a compliant standpoint. So you need the application of AI to that area to be able to interrogate all of that activity.
Okay, great. And your name was?
Paul Mahdi from MAS.
Okay, thank you.
Hi, my name is Ahmad. I run a consulting firm. I'm a programmer, and I have programmers who build systems for financial services, most of the big banks. And I want to ask, specifically in terms of AI, I studied computer science, bachelor's and master's, and most of my time talking to clients is not really writing code, but managing expectations because of the hype that people have about AI and consciousness and philosophical, intellectual BS sometimes. So
it's us professors who are setting those expectations that you have to manage.
So maybe along those lines, but for the computer science professor, if you studied Marvin Minsky's work and from the 80s and the AI winters, if you really think about it, really nothing new has been really extremely developed in AI. It's mainly more computing power, but nothing in the theory of it. And so yeah, I mean, what's your comment on that? I've always argued with people about how AI is part of computer science, not part of philosophy. There's no machine. But yeah, I mean, has there been really big changes if you think about from a technical perspective? Or is it just the fact that we can upload stuff to the cloud and process better?
Okay.
Great. In terms of cognizance and what decisions are we making, how structured they are versus complex human decision. Anyway, yeah.
Okay, great, thanks. We'll take one final question and then we'll throw it open for answers. Yeah.
Hi, I'm Maria Dalbert. My question actually relates to some of the questions you raised about fairness. I'm particularly interested in areas of financial inclusion, and I was curious your thoughts on beyond not being able to keep up. I think there's an assumption that almost inherent in the framework that there is a baseline of fairness in the data sets that exist, and in fact some of the challenges in the tightness of regulation these days is that they actually are reasserting the limitations in what data is used, how do you know who somebody is, around KYC. And so I was curious about your thoughts on how does AI partner to open up the understanding of what is a fair set of data, a fair set of algorithms and decision trees, because those seem actually regressive in many ways because of the current environment.
Okay, great, thanks. So I'll just summarize. The first question was about whether we should reject passivity and make machine learning a component of sort of some of the decisions that we're talking about. The second question was, is payments the sweet spot for sort of AI applications, because we need instant payment and you can't have humans do compliance there. The third question asked for a comment on is the only new thing about AI today the fact that we've got sort of massive new gobs of computing power. And the final question was about sort of creating a baseline for fairness in sort of financial inclusion and sort of more definitional issues. So I throw it open to the two of you.
Could be here all day.
So,
well, we do have, what, seven more hours before the reception? Yeah.
Well, I guess I can start with the one about managing expectations and whether there's anything new. I think it's a little uncharitable to say that there's nothing new. I think that the fact, I would not, and maybe it's just because I have low expectations, but I would not have imagined that I would see in my lifetime a system where you type in one language and the correct answer comes out in another language instantly, right? I would not have imagined that that would happen in my lifetime. And I've been in AI, for 38 years. I'm indicating my age here. I would not have imagined that
when you were born.
I would start, yeah, exactly, close to it.
In the womb.
I would not have imagined that we'd have cars driving us around autonomously. And that a famous philosopher, Hubert Dreyfus, famously said in '72 that machines could not be intelligent because they wouldn't perform basic tasks like driving. So I think the proof is in the pudding, right? We're seeing some really powerful technologies emerge and powerful capabilities. So there must be a basis for why all of this stuff actually seems to work. Okay. I have a harder time describing it in one sentence or saying, here's the theory behind it. But I think collectively there's been a lot of progress in bits and pieces, and we're seeing the impacts of that. I don't know what you feel, Michael.
Well, since you answered that one so eloquently, let me try to just move around here a little bit and maybe address these pieces of the first and the fourth questions, which I think are related in some ways. So if I understood the first question, it was about, what about the possibility of providing machine learning or algorithmic tools to consumers to participate in some of these decisions that seem to be moving towards automation? And I'm personally all for that. Of course, one of the difficulties is that it's not just the machine learning tools, it's kind of who controls the data, right? And so this would involve also giving access to the data that's being used to make your mortgage decision to you. Much of that data is proprietary, and these days your online behavior often gets fed into credit scoring models and things like this. But I'll take maybe even a more philosophically extreme question in the same direction, or comment in the same direction, which is, I think it's entirely reasonable and important for society as a whole to, kind of collectively decide what types of decisions they think machines should and shouldn't be made. And so, this sort of subfield of AI that thinks about ethical questions, there is debate about this. And to give one example of an extremal point, I think many people believe that in automated warfare, for instance, the decision to kill another human being should never be made by a machine or an algorithm, even if the machine or algorithm was much more accurate in some sense than human decision makers, just because there's like a moral agency to that decision that a machine cannot possibly share. And so even if the human being is going to make more mistakes, you don't want algorithms making the decision. And so I think that this is actually sort of an important discussion for society to be having as a whole.
I mean, it's interesting you bring that up.
It's about sort of drawing boundaries, right?
Because I'm reminded of Wendell Wallach and his sort of his effort over the last 5 years to try to get governments to commit to this,
right,
unsuccessfully. And
right.
sort of, and this seems like an obvious one, right?
Yeah, yeah.
And so does that sort of highlight a more general problem?
Yeah, and I mean, many of you may have seen these kind of philosophical conundrums around self-driving cars, where your self-driving car has it's lost its brake system, and so it has a choice of either saving your life by plowing into a crowd of school children or taking a left turn into a wall and killing you. What should the algorithm do? Yeah. And so these things are kind of parlor games in some ways, but they're getting at, I think, important issues for us to be thinking about. On the last question about, kind of fairness and inclusion in finance, which again I think is a very important issue, I think we should remember that things like discrimination and bias were with us before there were computers, right? And so it is important to remember that, these trade-offs that I talked about, the only thing that's kind of new here is our ability to quantify those trade-offs in a scientifically precise way and study them and decide where we want to be on the trade-off. But these trade-offs were always there when human beings were making criminal sentencing decisions or loan decisions or what have you. And so it's important that we not try to expect too much from algorithms and machines, right? We can't expect them to be perfectly fair and perfectly accurate, but we can, at least as a starting point, ask that they, not be worse than the discrimination and bias that human decision makers made. I think one of the biggest concerns about sort of the moving from human to algorithmic decision making in these sensitive areas really has to do with the scale and uniformity of decision making. So, there have always been like racist loan officers, right? And so in the old days, you'd go to your neighborhood bank, and the loan officer would deny your loan, and they wouldn't tell you it's because of your race. They would make up a bunch of other reasons. But at least in that era, there was the chance that if you were denied the loan at one bank, maybe you could walk to the bank next door and get a completely different decision from somebody who wasn't a racist. Now that racism, if racism and discrimination are baked into statistical models, and for instance, there's really only a couple of credit scoring companies, that generate all of our scores. These days, if you're rejected by a loan from one bank, the conditional probability that you're going to be rejected by all of the banks is extremely high, because they're all using the same models derived from the same data. And so, just the scale and uniformity of the decision making that's possible with algorithms, I think presents kind of a special danger that we need to be very vigilant about defending.
Okay, so I'm getting signals that we need to wrap up. So. Vasant, do you have any sort of closing thoughts before I wrap up?
No, I was just actually going to respond to one more question, which is that, yeah, I agree that payments is a sweet spot. In fact, it's also one of the vehicles for inclusion in India, right? Yeah. You're seeing more payments happen, and so you're seeing the potential for now people to actually make loans to these people who are making payments. So those two things actually can even go hand in hand.
Okay. So just to sort of wrap up in 30 seconds, it seems like we've sort of seen both a framework for thinking about when will computers make decisions and when will humans, and what kind of how will that frontier move, and sort of the beginnings of what seems to be a tremendously important sort of discussion about as we sort of start to delegate decisions more and more to robots in the financial services space, how do we integrate sort of issues of fairness? Seems like there are industries ranging from sort of robo-advising to mortgage lending, all the way down to financial compliance, which I think is going to sort of be automated at a pace that is greater than many others, and not just in payments, where we're going to sort of see a lot of automation over the next 10 years. And I heard Michael sort of call for more theory in thinking about sort of how to address the issues of fairness. I heard Vasant call for lowered expectations in, what we place in these AI systems.
Those two go well together,
yes,
by the way.
And, I just wanted to conclude by thanking Kathleen and Raghu for, putting together such an amazing program that you're going to sort of see play out after the break. I was thankful that you introduced me, Kathleen, and not Raghu, because he used to be my professor when I was in grad school. And every time he introduces me, he tells an embarrassing story about me in grad school. And so it was nice to sort of see the upside and the more recent, a more recent view of me. Thank you again, and let's wrap up. Yeah.
Thank you. Really great job. Yeah. Okay, so That was amazing. So we're running like 15 behind schedule. So if you guys could be back in here by quarter of, which is a time for a quick coffee, bathroom break, whatever, come back here quarter of, no later, okay? Thank you.